the equation here, so just move the equation to somewhere where we can see it. So this gives us this is our regression line, correct? And which is the slope of the line here? What is the slope of the line? 1.01, right? That is the slope of the line, meaning that is the beta of the stock, right? 1.01. 0.0053 is the y-intercept, okay? And I will explain in a sec what that is. Actually, there's a problem in chapter 9 that sort of uses this information. And the r squared is 0.2873. That means r squared does what? R squared measures the goodness of fit. Yeah. So 28.73% is r squared. Yeah. And I'll explain all those. Yeah. Now we're ready to do the data analysis. Okay. So for the data analysis, go to data. Okay. And you have the analysis here. Just click on that, the analysis toolpath. And when the window pops up, select regression. Okay. All right. Now, input Y range and X range. So usually what I do is, I minimize the window. So Y range, remember Y will be our stock. Okay, so for the Y range, we will select our stock. And for the X range, we will select our market. We'll select our market. Everything else can be the default setting. Okay, you don't need to change anything. So you see here the radio button, new worksheet fly is active. So that means when we click OK, the table will be put on a different tab, okay, on a new worksheet. So once we get the table, just adjust the columns a little bit so we can see what's going on. All right, the first thing we do is make sure you check, see this is the intercept and this is the x variable. So the first thing we do is make sure that these two numbers match what we got here on the table. Okay. So on the table we have our beta was 1.0169. Let's go and see. Yes, 1.0169. And the y-intercept was 0.0053. Y-intercept is 0.0053. So the data, the answer matches. Okay, so sometimes when you do it, you may forget a number and you select, right? So it doesn't match. So make sure that's once you get your ANOVA table, the first thing you do is make sure that your answers on the ANOVA table matches with that of the chart. That's why you always do the chart, just to make sure that you get the correct answer, okay, twice. Also, your R squared, there are a bunch of R squares. They give us the multiple R, the R square, adjusted R square. But all we are going to use is this regular R square, okay, which is 0.2873, and that also matches here. Okay, R squared equal to 0.2873. Okay. So everybody good with this? Okay, so this is as far as you need your Excel. So now we are going to analyze this table. Okay. And like I said, there's one problem in chapter 9. I don't exactly remember which problem, but that uses, and I've actually used that problem to I've used that problem to design the questions. Okay? And this is kind of what you will be looking for in your paper as well. Okay? So this is my table. Okay? Now, the first question is, what is the y-intercept of the regression, and what does it tell us about the performance of the company stock over the period of regression? Okay? So the y-intercept is this, correct? So when we got the chart, right, this is our regression line. So this is basically our y-intercept, right? So this is what we have here, 0.0059. Gosh, I feel important. People recording. 0.0059, okay? So now, here, what I've done is I have, remember these are decimals, okay? So it just happens that this is equal, but this is the so I put, just for my convenience, I put the risk-free rate, the market risk premium, the beta of the stock, and the y-intercept here, okay? Just on one side, just for my convenience. You don't have to do that, okay? So this is the risk-free rate that we are going to use, 2.19%, and this is the market risk premium we are going to use, 6.33%, okay? And this is for all of us here, okay? And this beta is whatever beta you get from your regression, and y-intercept is whatever y-intercept you get from your regression. Now the question is, how do we measure the firm's performance? Okay? So when we are using the way that we used our regression data or our returns data, when we compute the firm's return, we always compare it to the risk-free rate multiplied by 1 minus beta. Okay? That is, we compare the y-intercept to the risk-free rate multiplied by 1 minus beta. Okay? And the way the interpretation is done is we say that if y minus, so I'm just going to subtract it, or you can do if y is less than, greater than, or equal to, if y minus the risk-free rate multiplied by 1 minus beta is less than 0, that means if it is negative, okay, if the number is negative, that means the stock performed worse than CAPM expectation. Okay? If it is greater than 0, that means stock performed better than CAPM expectation. And if it is exactly equal to 0, that means stock performed at par with CAPM expectation. Okay? And there's a little bit of math involved where we can show why we are using RF1 minus beta. What is the reason that why we're using? I'm just not going to do the math, okay? But believe me, there's proof for it. Okay, I'm just not saying that because I want to. Okay, so there is proof why we have to use RF1 minus beta for comparison purposes. Okay, and that is what I have done here. So intercept, and it so happens that you see this is mine comes exactly the same. And it's just coincidence. Okay, so intercept minus RF1 minus beta, I get 0.59. Okay. So what does that mean? This means that my stock, so this is positive number, okay? So this means that my stock performed 0.59%, and this is in percentage, 0.59% better than CAPM expectation. Okay? However, the data that we have downloaded is, remember, monthly data. Okay? So the result that I get here is a monthly result. So it performed 0.59% better on a monthly basis. Okay? But have you ever heard of anybody saying that, hey, my investment performed, X percent over a month? No, we always talk in terms of annualized returns. Okay? So once we get the monthly returns, the next step is to compute the annualized returns. So if we are annualizing returns, how do we do it? So you used your financial calculator in 501, right, where you change your N to 12 payments per period, and you basically use shift NOM and shift EFF. Or the other way, which I like the best, is simply using your equation. Okay? I actually have the equation here. I think that's the way I did it. I must have used the equation. Right. So you basically go 1 plus your monthly risk-free rate, that was my 0.59, divided by 100 raised to the 12 minus 1, your compounded rate. Okay? So I always like using the equation, but you are welcome to use whatever you're comfortable with. If you like your calculator, feel free to use the calculator. But that's your simple equation for computing annualized rate. So once I do that, my answer is 7.37%. So what does that tell me? That my Bed Bath stock performed 7.37% better than CAPM expectation over my period of regression. Clear? Okay. If I use some other data range, it will change. Okay. But over my period of regression, my stock gave me 7.37% better, outperformed CAPM expectations. Okay. So that is the interpretation of the Y coefficient. Okay. Now the problem here is that if you look at the T statistic, okay, the T statistic is 0.7 with a p-value of 0.48. What does it tell me about the significance of this of the y-intercept? Because the null for the y-intercept is what? You know, null and alternate, right? Null hypothesis and alternate hypotheses. The null for the y-intercept is what? That y equal to 0. That is, the stock performed exactly at par with the pattern. Okay? And the alternate is y is not equal to 0. Okay? But here you see my p-value. My p-value is way too high. Okay? My p-value actually cannot reject the null because it's way too high. Okay? So since my p-value cannot reject the null, I must say that although my result looks good, but in actuality, my stock performed at par with the CAPM. It's no different from 0. Understood? That's you know, you can still do this part, but just so you know the meaning of the significance. Okay, this term is actually not significant. Okay, so if you get this result for your stock, you've made an investment in the stock and you get this result and you say that, hey, that's great, I actually earned 7.37% better. But then you look at the significance, then you say that, no, that's not true. Because my probability is so high, it actually cannot reject the null. Okay? So my null actually still holds true. Okay? So the next one you'll see that the probability for the data is actually pretty good. So that's my annualized excess return. Next is, what is the slope of the regression? So slope of the regression is beta, okay, and we saw that it's 1.01. And what does it tell us about the risk of the stock? When we compare, remember when we get the beta, we're doing, it's sort of at par with the market, right? It's about, you know, market is 1%, so we can say that, I mean not 1%, market beta is 1, and we can say that our stock's beta is 1.01. So slightly more risky than the market, right? Slightly more risky than the market, but you know, compared to the market, it's pretty close. Next is, how precise is this estimate of risk? Now here is where our confidence interval comes in. Remember our 67%, 95%, 99%. Now on the ANOVA table, Excel actually already provides us with the 95% confidence interval. Okay, this is 95% means how many standard deviations? 2 standard deviations. Okay, so how is this calculated? So you know, you actually don't even need to calculate it using the standard error. Correct? We don't care about the y-intercept. We just care of the beta. So 1.01. Say I round it off to 1.01. So the lower 95% is obtained with 1.01 minus 2 standard deviations, so 2 multiplied by 0.1933, 0.19. And the range of the beta will go from this to 1.01 plus 2 multiplied by 0.19. So this number, and you can do the math and check, 1.01 minus 2 times 0.19 should be equal to 0.625, and 1.01 plus 2.19 should be equal to 1.39. That is, we can say with 95% confidence that our beta is going to lie somewhere between 0.62 to 1.39. Understood? That's the interpretation of the confidence interval. And if this is 2 standard deviation, 95%. If it's 67% confidence intervals, then we simply do, it's 1 standard deviation, so minus 0.19 to 1.01 plus 0.19. Right, this is our 95, and this is our 67.